Hello, I'm Peter Ross and welcome to the Power Saving Centre. We're at 133 Musgrove Street, North Rockhampton in Queensland. Our whole objective is to try and save you, as the house owner, energy on your power bills. And one of the highest energy users in a home is an electric hot water system. So today, I'm just going to go over a couple of options on how to combat that. Now, we've just spoken about the panel and how the panel has heated the water. What we've got to think about now is where that hot water is going to go. Now, in the roof-mounted thermosiphon system, you have a tank that sits up above the panel. This is the panel that we were talking about before. The water heats up because of its molecules are lighter, rises to the top of this panel. There's a tube that runs along the top of this panel, so there's water in the tubes in this panel. When it heats up, it rises up a hot pipe, and then the hot pipe is connected into the back of the tank. So that hot water rises, comes up into the top of the tank, and then there's a cold pipe, I'll lean over, connected into the bottom of the tank, and it drops down to the bottom of the collector. Now, if we come over here, what that does is that you've got the cold pipe with the cold water that's stored in the tank from the night before. It falls down because it's heavier. It comes along into the bottom of the collector. Now, you can have more than one collector on these as well. In some cases, you can have 3. When that water heats up, it rises up in the copper tubes, like we were saying, comes up the very top rail, or there's a tube that's in the top of the collector. It comes up, it rises up into the tank and sits at the top of the tank. Now, it just keeps thermosiphoning around. So this cold temperature here, it can be at 60 degrees. It's still classed as colder, and it will fall, and then the hot water will rise. At night time, when the sun stops shining and it's cold at night time, then all the water falls to here and it stops thermosiphoning and it stores all that energy in that tank. It can store the hot water for days up in that hot water, depending on how much you use. Now, in the tank itself, we've talked about how the tank gets hot, so we can forget about the panels for a minute. Up here, you've got your normal electric hot water system at home. If you go home at the moment, you turn on your hot water tap, you fill up the sink full of hot water, go downstairs, lift up the meter box and have a look in. By about that time, you'll see that the electric meter will start spinning. The reason for that is that you may need to come in a bit closer here. Down here, we've got our power supply. Let's get rid of that at the moment. Our power supply comes down to an electric element that's in the bottom of your hot water system. So it's a 300 litre electric hot water system. When you have a shower, wash the dishes, you draw hot water out of that tank and cold water comes in from mains pressure and starts filling up that tank with cold water. That's how you get hot water out at the top of it. What happens is when the cold water comes in, it mixes around, they call it stratification. It comes in here and there's a thermostat that says that the tank is cold. Even though that you might have 250 litres of hot water above here, this thermostat says, no, I must keep it at that full 300 litres of hot water. So the electricity fires up and starts using electricity to heat your water up. Even if you're rinsing a coffee cup, basically. Up here, in the storage tank of the Chromogen, what they do is the hot pipe that comes out of the top of the tank, instead of it just being straight, they put a curve on it. So it comes right to the very top of the tank. So you get millimetres above the tank. So it sucks every little ounce of hot water out of the tank, so it's not wasted hot water above it. If you've got a bucket of hot water and you put a garden hose in it and turn it on, what will happen is it will mix very, very quickly. It'll spray in there. So what Chromogen do, and I'll grab a brochure, bear with me for a second. I'll grab something. What happens is when you turn on your hot tap, cold water enters this pipe. So what they do is they put a little baffle inside the tank. So when the cold water comes in, it hits that baffle and lays it right very slowly in the bottom of the tank. So the pressure's the same, but what it does is it fills up very, very gradually. Now, you've drained out the hot water. Let's say it starts raining for a month straight and you've got 10 people staying in the house and it's a 300 litre system. When initially you will come up here and you would run out of hot water because there's no more sun on the panels at all. So it has to have a backup. So what you do when we do the installations of them, this gets disconnected and this electric here if the pen works, this electric here gets connected up to the thermostat and it heats the water up via an electric element. Virtually exactly the same as this system. It still can be put on an off-peak tariff as well. So let's just say that the power is turned off to the system. You drain all the hot water out of it. You turn the switch on down here. When it heats up down to that halfway point, the thermostat will automatically cut out and it won't turn power on until you use power again. So if you went for a trip around Australia, it's not going to use any electricity because the sun eventually will heat the water below it. With that whole entire principle, that's the most efficient system because there's no pumps in it. The benefits of it is that if you've got an electric hot water system, say in your barbecue area out the back, you can get rid of that electric hot water system. If you've got a small home, the electric hot water system is in a cupboard. They call it a space-saving system. You can remove that electric hot water system. It's gone from there. But you're not using the electricity like you do with a system like this. So what we'll do, we'll finish it there and we'll talk about another product shortly.